let's look at an application where we're going to use the trig values to write component forms of vectors. Exercise 12. Suppose an object is positioned at the origin. One force, so a force of 10 newtons, acts on the object at an angle of 187 degrees with the positive x-axis. A force of 20 newtons acts on the object at an angle of 246 degrees with the positive x-axis. Determine the single resultant force acting on the object. In which direction is it acting? So what this is really asking is, okay, there's this object and two different forces are acting on it. So what is the result of that? And so the result is going to be a force of some magnitude acting in a certain direction, and we want to find that. So first, I think it helps us to draw this and just to kind of picture what's going on. And we're going to think of each force as a vector. We're going to want to picture it that way. So this first one says a force of 10 newtons acts on the object at an angle of 187 degrees. So the 10 newtons is going to be the magnitude, and we can see this angle here is 187 degrees. So 187 degrees is just below, that full 180, kind of that half rotation here, down in quadrant 3. So I'm going to label the angle 187 degrees. I'm going to label the vector just with its magnitude of 10. And then I want to call this, since it's kind of the first force that's mentioned, I'm going to call it F sub 1. And now we have this other force. It says a force of 20 newtons acts on the object at an angle of 246 degrees with the positive x-axis. So 246 degrees, where is that? Well, 270 is straight down, so we can just kind of draw it somewhere over here. Its magnitude is 20 newtons, so that's why I drew it about twice as long as the other one. So I'll put that 20 there. I want to label this angle somehow. I'm running out of room here, but this angle here is that 246 degrees. And let's call this one F2. And so what happens is, in order to find that resultant force, the resultant force is just going to be F1 plus F2. So in order to find out something about F, the vector that we're after, so the resultant force, we just said the resultant force, right? That's the one we're after. We're going to call that F. We need to know something about F1 and F2. Okay, so let's do that first. So F1 is, we want to think about it in component form. So it's going to be something I plus something j. And we know that it's really just the magnitude of the vector. So this magnitude of F1 is 10 times the cosine of its angle in standard position. So in this case, 187 degrees plus 10 sine of 187 degrees. So that's just from our definition of using trig values to write vectors in component form. Okay, let's do the same thing for F2. So F2 is now going to be 20 cosine of its angle, which is 246 degrees. And notice we're given these angles that are like not nice ones from our unit circle. So we'll have some approximation at some point. Plus 20 sine of 246 degrees j. So now I've written both F1 and F2 in component form. It's kind of my first step. So now what would F be? All right, I'll make a lot of room here. So F is going to be the I components, right? The horizontal components added together, and then the vertical components added together. I'm making myself just a little more room here. Okay, so I can see the horizontal components are just going to be, 10 cosine 187 degrees plus 20 cosine 246 degrees. So that's my horizontal component, plus 10 sine of 187 degrees plus 20 sine of 246 degrees. Okay, so now I am ready to, I need my J, all right, and so now it's written in component form. Well, now I need to, that single resultant force is going to be the magnitude of my vector F here, and then in which direction we can find that. Okay, so let's first find its magnitude. One thing that might help us, I guess, backing up here, one thing that might help us is to determine these approximate values, because the calculations from here are just going to get pretty messy. So if we can determine some approximate values to 2 or 3 decimal places, that should be enough to get us an accurate enough answer at the end. You can always expand and use more if needed. So let's do that. So I'm going to calculate, make sure I'm in degree mode since these are in degrees. So I see it that I'm switched over to degree mode, and I'm going to have just 10 cosine of 187 plus 20 cosine of 246, okay, parentheses. So negative 18.060. So because I got that last zero there, I'm going to say this is about negative 18.06. Call that good. And then let's see, what do I need for my other one? The other ones I just need sine. Let's see if I can just delete these and put in sine. And then delete this one. Put in sine. That's getting a little messy. Let's not do that. Okay. So let's see. I need 10 sine of 187 parentheses plus 20 sine of, what was my other angle? 246. So I get negative 19.49. So this will help me just do my calculations from here because, again, it gets a little bit hairy. Okay, so what is the magnitude of F? Well, that's going to be the resultant force. So it's just going to be the square root of, and again, I'm using these approximate values. And if these are not exact enough for homework or something like that, you can always just, like I said, extend the number of digits that you have to the rate of the decimal point. Okay, so what does this give me? So back over here. Now we want the square root of, let's see, parentheses, negative 18.06, parentheses, squared, plus, parentheses, negative 19.49, parentheses, squared. So about 26.57. And since this is the resultant force, this is going to be in newtons. And now we are ready to find, like, at what angle is the resultant force acting. Okay. So I know that I can do tangent inverse of vertical over horizontal component. So here's my vertical over my horizontal component. Let's see what that gives me. So go over to tan inverse in the main menu, and then negative 19.49 divided by negative 18.06. And the two negatives in there will end up canceling out, and the calculator knows what to do. So I get 47.18 degrees. But I notice that that is an angle in quadrant 3. So this lives in quadrant 3. But notice that my horizontal and my vertical component are both negative. So that's going to live down here in quadrant 3. And so what I need to do is add 180 degrees to 47.18 degrees to get my angle theta. So angle theta is going to be 47.18 degrees plus 180 degrees, which is, let's see, I can just do answer plus 180. I get 227, so about 227. I guess I need my approximation symbols here. Let's say 0.18 degrees. So where would that live? Well, we know that 225 is that main diagonal in the third quadrant. So if I wanted to draw this, let's see, it should be a little longer than F2. So maybe like here and about on that main diagonal, and this would be my angle F. And then here's its angle, drawing it really big here, its angle theta, and then its magnitude, or length, would be here. And again, we're thinking about that in terms of newtons because that is a force measurement, force unit, and then this 227.18 degrees is just the angle with the positive x-axis. So if you're asked a resultant force question, what you really want to do is think about the resultant force as the vectors of the two forces added together. If there's 3 forces or more, you could add those in there as well. Okay, and then, so that's kind of step 1, is to think about it that way. Step 2 is to think about F1 and F2, get them into their component forms, and so using those trig values is really going to help, right? Because we use the magnitude and the angle there. And then we can write vector F as just the sum of F1 and F2. Once we do that, we find the magnitude to find the force of F, and then we find the angle to find the direction.